back, 6th grade. Welcome back. Let's look. Go ahead and get your notebooks out and get your pencils out. Go ahead and turn to a clean sheet notebook paper. Go ahead and write today's date. Let's go ahead and copy down our I can statement today. Our I can statement is, I can evaluate numerical expressions involving whole number exponents. Now, last time we talked about exponents and how exponents can be represented many different ways depending on how you view or how you look at a certain problem. So I have 3 different algebraic problems on my board here. My question to you is this: am I going to get the same answer for all 3? Go ahead and give you a second there. All right. So, do you think we're going to get the same answer for all 3? You're right. We're not. If you notice here, there's a certain kind of problem with each of my problems I have here. And that is looking at the what? That's right, the parentheses. That is correct. So looking here, my parentheses is placed differently throughout these problems. Now, if you remember, we talked about this a long, long time ago. That's right, PEMDAS, the order of operations. Looking at this problem, the order of operations applies to every single problem we have here. So let's go ahead and go through each one of my problems here to get our answer. Looking at my first one, I have 2 parentheses, 5 plus parentheses 3, parentheses 2, plus 4, close parentheses. Now, as we talked about before, when we have a parentheses that is next to each other, that means multiplication. So when doing order of operations, you have to look at the order, or you have to do parentheses first. So, in my parentheses, you want to do multiplication first. So 3 times 2 gives me 6. So now I'm left with 5 plus 6 plus 4, which will give me, when added together, 15. So 15 times 2 will give me 30. All right, let's look at the next problem. In the next problem, we have 2 parentheses, 5 plus 3, parentheses, 2 plus 4, parentheses, close parentheses. Now we have double parentheses. So like before with PEMDAS, we have to do our outside, or we have to do our parentheses first. Now, in here, unlike up here where I multiplied 3 times 2, I have to do the parentheses on the inside. So 5 plus 3 will give me 8, and 2 plus 4 will give me 6. Now I have 8 times 6 because my parentheses are next to each other, so 8 times 6 is 48. So now let's do 2 times 48. Can anyone tell me what 2 times 48 is? You can already see some of you are confused, so let's go ahead and go through this. 2 times 8 is 16, carry the 1. 2 times 4 is 8, carry the 1 is 9. So we get 96 for our next parentheses, which, as you know, does not look like 30 at all. Let's look at our last one, shall we? This one's the most difficult, I believe. 2 parentheses, 5 plus 3 parentheses, 2 plus 4 parentheses, parentheses. Now, just like before, we have to follow PEMDAS and do the parentheses first. So, 2 plus 4 we have to do, which is 6. 6 times 3, because multiplication comes next, 6 times 3 will give me 18. So now, 5 plus 18 is what? Can anyone tell me? That's right. If we look here, 18, 19, 20, 21, 22, 23. You are correct. So now we are at 2 times 23. Now, can anyone tell me what 2 times 23 is? I can't stump you guys at all. You guys have been so smart today. Yes, 2 times 23 will give me 46. So my question to you is this. What do you notice? Or what is the key here looking at my first problems? The parentheses. You are correct. Depending on where the parentheses is placed, it can change the value in my problem because of order of operations. You are correct. So, now let's apply it to some exponents now. Let's say, hypothetically, just like with parentheses, there are different ways you can look at an equation. Now let's say, for example, I have 2 squares here. And let's say these squares, because we all know about squares, they have the same sides on all 4 sides. Let's say I have a square here and a square here, and this one measures 2 on every single side and 5 on every single side in this problem. And I wanted to then see or simplify this using exponents. Well, looking here, I know that if I wanted to explain or find the area, to find the area of my square, I do 2 times 2. So let's see, 2 times 2. We've talked about that before. Could I not make this 2 squared? So if I make this 2 squared, what could I make this square? 5 squared, you are correct. So another way I could look at this problem is I could look at it as 2 squared times 5 squared. You are correct. Let's look at another one. Let's say I were to have say I had 2 squares. This square was 5 and 5. This square was 5 and 5. What's another way I could look at it? Yes, we can use the power of exponents. Now there are 2 ways I could write this. 5 times 5 could just give me 5 squared. And 5 times 5 could give me 5 squared. So I could end up with 5 squared times 5 squared. Or we could look at another way. Let's say I had 5 times 5 times 5 times 5. How many 5s do I have? That's correct. I have 4 5s. So I could also write it as 5 to the 4th power. Questions on that? If you got any questions, please feel free to give me a shout out or give me a buzz on the old phone, and I'll be happy to help you with any questions or concerns you have. All right. So, homework tonight will be posted on Google Classroom for you to complete. There'll be a few sample problems regarding this type of algebraic thinking. But now let's go ahead and look at our exit slip, okay? Please. Number 1, 39 divided by 2 plus 1, close parentheses, minus 2 times 4 plus 1. And let me give some space here. And my second problem is 12 times, parentheses, 3 plus 2 squared divided by 2 minus 10. I'll go ahead and give you a minute to pause to answer those 2 questions, and then we'll go back and solve them. All right, let's go ahead and solve these problems, shall we? All right, looking at PEMDAS, the first thing, like we talked about earlier, is parentheses. So, let's go ahead and do our parentheses, shall we? 2 plus 1 And 4 plus 1 is the first thing we're going to do in this problem because it's parentheses. So let's go ahead and, as I've done before at school, let's go ahead and bring everything down that we're not going to do yet. So 39 divided by 2 plus 1 will give me 3 minus 2 times 4 plus 1 will give me 5. All right, so I've done parentheses. Check. Do I have any exponents? No. Okay, check. Do I have any multiplication or division? Yes, I have multiplication. 2 times 5 is what? That's right, 10. Now, one thing though, as I've told you guys before, and many of you guys have gotten tripped up by this, when I have a negative to the left, remember, to the left, you want to multiply it. So this is really a negative 2. Negative 2 times 5 will give me negative 10. So now I have 39 divided by 3 minus 10. All right? Now what's next? Right, division. So 39 divided by 3. So for those, let's go ahead and do this together, shall we? 3 goes into 3 how many times? Once. Bring down the 9. How many times 3 go into 3? Or I'm sorry, 3 go into 9? 3 times. So the answer is 13. So now I have 13 minus 10, which is 3. All right, let's look at the number 2 now. So number 2, I'm actually going to bring up, because it's going to take a little bit of work to do. So 12 times, parentheses, 3 plus 2 squared divided by 2 minus 10. All right. So, looking at my PEMDAS here, parentheses is going to be first. Now, in my parentheses, we have an exponent. So we're going to have to do that first. 2 squared is just 2 times 2, which is 4. Right. So, 12 times 3 plus 4 divided by 2 minus 10. Okay, what's next? Well, we still have that parentheses, so we have to do 3 plus 4. 3 plus 4 is what? 7. You are correct. So, 12 times 7 divided by 2 minus 10. What's next? Multiplication. You are correct. 12 times 7. Let's go ahead and do that. So 12 times 7. 7 times 2 is 14. 7 times 1 is 7. Add 1 is 8. So we get 84. 84 divided by 2 minus 10. What comes next? Division. 84 divided by 2. 2 goes into 8 how many times? 4. Subtract it. Bring down the 4. 2 goes into 4 2 times. So 84 divided by 2, or 84 cut in half, is just 42. And 42 minus 10 is 32. So going back to our I can statement today, I can evaluate numerical expressions involving whole number exponents. As you can see, combining exponents back into our problems and doing order of operations, we're still able to get our answer. Thank you for joining me for this lesson. Tune in next time when we delve more into exponents. Thank you.